So guys, welcome to our channel once again. In today's video, we have here at least 10 questions to answer on the topic magnetic field. So guys, this video will be about the concept of magnetic field. So in short to stay till the end of this video. Let's go ahead and start with the first question here. It says, which of the following statements about magnetic lines of force is not correct? They A are in a state of tension and tend to be shorted. B intersect one another. C. Pass through even non-magnetic materials. D. Run from the North Pole to the South Pole. So guys, the option here that is not correct here is option B, intersect one another. So the magnetic lines of force do not intersect one another, and as such, option B is the answer to this question. So let's go ahead and consider the next question. So that's question number 2 here. It says, the part of a bar magnet at which the magnetic effect is strongest are called the A. poles, B. magnetic declination, C. magnetic meridians, and D. neutral points. So guys, the answer to this question is option A, and that's the poles. So the poles are the regions or the parts of the magnet at which the magnetic effects are strongest. So that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 3. It says, a student uses 2 compass needles to investigate the magnetic field around the bar magnet. Which of the following diagrams show the correct directions of the needles? Alright, so the correct answer to this question will be option D here. And that's here. The one placed at the middle here will move towards the south point, and then the one that is placed at this region will be attracted to the magnet at the south. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 4. It says, magnetic flux density is defined as the A. number of magnetic lines of force per unit area normal to the magnetic field. B. total number of magnetic lines of force surrounding a magnet. C. strength of the magnetic field surrounding a current carrying conductor. And D. magnetic field exerted on a unit magnetic pole. So guys, the answer to this question is option A here. The magnetic flux density is defined as the number of magnetic lines of force per unit area normal to the magnetic field. And that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 5 here. It says, 2 bar magnets are placed near each other. Which of the following diagrams correctly illustrates the magnetic field pattern formed by the pair? Alright, so we have here these diagrams as the options. So you'll notice that the magnetic field pattern that will be formed here will be such illustrated in option D here. So option D is the answer to this question here. So you see the field pattern where you have the North Pole and South Pole here inverted against the South Pole and the North Pole. So guys, in this diagram here in option D, you notice that at each point the North Pole is attracted to the South Pole, and that's it here. The direction here of the magnetic field is always tending towards the South Pole here at each point. So that's it here. So let's go ahead and consider the next question. So that's question number 6 here. It says, the region around a magnetic field in which magnetic force can be experienced is A. flux density, B. flux, C. declination, D. field. So guys, obviously the answer to this question is option D, and that's field. So let's go ahead and consider the next question, guys. So the next question here is question number 7. It says, the conclusive test for magnetism in a steel bar suspended horizontally at its midpoint is when the bar A. Always settles in the magnetic east-west direction. B. Always settled in the magnetic north-south direction. C. Is repelled by a magnet. D. Is attracted by a magnet. So guys, the answer to this question is option B here. So the conclusive test for magnetism in a steel bar suspended horizontally at its midpoint is when the bar always settles in the magnetic north-south direction. So that's it for this question. Let's go ahead and consider the next question, guys. So that's question number 8 here. It says, the region around the magnet in which the magnetic influence is experienced is called A. Magnetic declination, B. Magnetic field, C. Magnetic meridian, D. Magnetic flux. So guys, the answer to this question is option B here, magnetic field. So let's go ahead and consider the next question, guys. So that's question number 9 here. It says, which of the following statements is not correct? A. Magnetic fields are scalar quantities. B. Magnetic field is a region in which magnetic force may be detected. C. Neutral points are obtained when the Earth's magnetic field is exactly equal to and opposite to that of a magnet. D. A magnetic line of force is a path along which a magnetic north pole would move if it were free. So guys, the answer to this question here is option A. The magnetic field is not a scalar quantity, and as such, option A is the answer to this question. So let's go ahead and consider the next and last question, guys. So the next question here is question number 10. It says, which of the following statements about magnetic lines of force is not correct? We have A. The presence of magnetic lines of force in a region indicates the presence of a magnetic field. B. Magnetic lines of force do not cross one another. C. A magnetic line of force is an imaginary line which the north pole of a magnet would describe if it is free to move. And then D. Magnetic lines of force are closely packed together at neutral points. So guys, the answer to this question is option D here. So that's the odd option here, and that's the only statement about the magnetic lines of force that is not correct here. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not yet a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So finally, guys, I want to use this opportunity to encourage you to join our YouTube channel community. Thank you once again for watching this video and see you on the next one.